In this video we're going to continue with differentiation, and this time we'll look at differentiating terms with negative and fractional indices. So just a reminder of what we learned last time. If we have f of x equal to x to the power n, then f dashed of x is equal to n multiplied by x to the power n minus 1. So you can see we're multiplying the term there by the power, the exponent n, and then we're subtracting 1 from that for the new exponent. So example 1, a function f is defined for x in the real numbers by f of x equal to x to the negative 3, and we're finding f dashed of x. Now just a reminder here that the question could have told us that f of x was equal to 1 over x cubed, because that's the same as x to the negative 3. So just be aware of your rules of indices from National 5 as well. It's really important for differentiation and the other branch of calculus, integration, when we get to it. So the solution to this one then, we've got f of x is equal to x to the power negative 3. Remember, we are multiplying the coefficient, which is currently 1. We've got 1x to the negative 3. So negative 3 multiplied by 1 gives us negative 3, and then we need to subtract 1 from the power, which would give us x to the negative 4. So f dashed of x is equal to negative 3x to the negative 4. Now we always should write answers with positive indices. So negative 3x to the negative 4 is the same as negative 3 over x to the 4. And that's our final answer there. Now we'll take a look at a second example, and then I'll give you the opportunity to pause the video and copy these down before we do a third example. So a function f is defined for x in the real numbers by f of x equals 4x to the negative 2, and we've to find f dashed of x. Now again, this could have been written differently. F of x could have been written as 4 over x squared. And we would have had to have changed it to 4x to the negative 2 before we could have differentiated. So it's worth noting that just now. So f of x is 4x to the negative 2, as we've said. We need to multiply our negative 2 by 4 to give us negative 8. And then x to the negative 2, we need to subtract 1 from the power to give us x to the negative 3. And that will give us negative 8x to the negative 3. And ensuring that we express that with positive indices, that will give us negative 8 over x cubed. And that is our final answer there as well. So before the third example, because the slide will change here, I would pause the video just now and copy these two down in your notes. Okay, welcome back. So look at example 3 here. So a function f is defined for x in the real numbers by f of x equals x to the negative 1/3. Find f dashed of x. So you can see here this time that we have a negative exponent, but we also have a fractional exponent as well. So that actually could have been written like this. So 1 over the cubed root of x. So if we'd been given that, we would have been expected to change that to x to the negative 1/3. And you can see the progression of the working there. So we've got f of x is equal to x to the negative 1/3. So we need to multiply the term by negative 1/3 and then subtract 1 from that exponent. So we get negative 1/3 x to the power negative 4/3, and that's f dashed of x. Now, we don't want that negative exponent. We also don't want this fractional exponent. So all answers should always be written with positive exponents and radical signs, that's root signs. So we need to change that. Firstly, we'll get rid of the negative exponent. So rewriting that as negative 1 over 3x to the 4/3. And that is the cubed root of x to the 4 that's on the denominator there. So we get negative 1 over 3 times the cubed root of x to the power 4. And that is our final answer there. So again, it would be a good idea to pause the video before the screen goes blank and take a note of this one in your notes as well.